This is October-November 2025, paper 22, and these are the grade thresholds for this paper if you want to score a good grade. Let's move on to the first question. We're investigating A pressures, and we want to confirm the base units of these quantities. So A temperature is Kelvin, so that's K, and it is a scalar. Pressure is also a scalar, but for the base units, we can simply use the formula, which is pressure equals to force over area. Force is MA and area is meter squared. This is mass, so this will be kg dot ms minus 2 divided by m squared. When this goes to the numerator, this becomes kg m minus 1 s minus 2. All right. So the base units of A pressure will be kg m minus 1 s minus 2. At one location, the density of the air is this. The spherical weather balloon is filled with gas released from rest. Important information, radius is this. Now, be advised that sometimes it's not radius, it's the diameter. Yeah, so you just have to be careful about that. So calculating the upthrust requires us to allow the Archimedes principle, which is the upthrust is equal to rho gv. V is the volume of the fluid that it is being displaced, or that is being displaced. So that is generally the volume of the balloon itself, because that's what is being displaced. So the density is 1.1 given in the question. G is 9.81, and then we have the volume. So since we're dealing with the balloon, this will be 4 by 3 pi r cube, which is going to be 0.90 whole cube like this. Put all the values like this as a single go in the calculator, and your answer will be 32.918 newtons, and your final answer will be 33 newtons. Explain why the upthrust acts on the balloon. So this is basically simple physics that he's asking you about, that why upthrust causes pressure or causes force. So the area or where the pressure actually comes from is simply the difference of density, the difference of height. So based on the different depth, for example, on the top of the fluid, at this point to this point, there's a difference of delta H. This delta H actually eventually leads to the pressure developed due the pressure difference, which eventually leads to the force applied due to the upthrust. So the force on the top area, on this area, is smaller, and the force on the bottom area is greater, purely because the pressure at the base is higher. So pressure is equal to force over area, and if this is rho gh due to liquid, then higher depth leads to higher pressure, which leads to higher force. Now surface area is generally the same because the top and the bottom areas have the same pressure. Same thing is happening with the sphere. The area is not the deciding factor, it's the difference of densities of air, slightly different densities. So for example, the air molecules could be like this at the top part and could be very, very closely, tightly packed at this point. So for example, if we want to visualize it like this is the balloon. The air particles on the upper region might be spaced like this, but on the lower region, they are spaced very close together. And of course, they are not going to be in regular pattern. They are going to be rough in terms of their arrangement, but this actually creates the upthrust like this. More molecules at the base, less molecules at the top, purely because of the difference of height leading to a difference of pressures, which is very, very tiny in this case, or it should be. It's not that big of a deal, or shouldn't be. Now, the weight of the balloon is 19 newtons. He says calculate the magnitude of initial acceleration of the balloon. Now, why is he saying initial acceleration? You see, the balloon was released from rest. This is why I said this is important information. So visualizing this as a single object, the weight is downwards 19 newtons and the upthrust is in the upwards direction as 33 newtons. So using Newton's second law, we have F equals ma. The resultant force is going to be 33 minus 19 equals, now for mass, we need the weight. So this will be 19 divided by 9.81. We've done this by using the equation W equals to mg. We want to find the mass. Weight 19 is given, g is 9.81. It goes there, it gets divided. So we're left with this. And then we have A. Your answer for A should be 7.22 meters per second squared, which is going to be here. Now, for the second C part, he says that we have a formula for C. This could be any quantity. We're not sure what that is. So he's mentioning about K, F, and V as some quantities mentioned. He says the calculated value of C is 1.8. When everything is put into this equation, C comes out as 1.8. He says determine the absolute uncertainty. So first we need to find the percentage uncertainty, multiply this with the calculated value, which is 1.8, will give us the absolute uncertainty in these calculations. So first we need to figure out the error function. The error function, as I would like to call this, is what things or what variables are actually contributing to the error in C. So that will be very simply C is equal to, or delta C divided by C will be equal to delta K divided by K plus delta F divided by F plus 2 times delta V divided by V. So every variable that was involved in this process will be responsible for the error. Now we are ignoring 2 for the fact that it's a constant. Since it's a constant, it cannot do anything. And for V square, we use the power rule that since it's coming twice, it's going to be 2 times error in V divided by V. Now what they have done successfully here in this is they've given us the value of delta K by K multiplied by 100. They've given us the percentage uncertainties of everyone. So if I were to multiply all of this with 100, this was already in the table. So it's my job to manipulate these numbers in a more intellectual fashion. So this one is going to give me 5%, and F was going to give me 3%, and this one is tricky. So this will be 2 times 4%. And our absolute error over C is still there on the left side. Of course, you can take some shortcuts and steps to solve this question much more quickly, but I'm solving this for everyone who's coming to the video. That's why I'm going into more detail at the moment. So this error is going to come out as 16% problem contribution total combined in the value of C. C is given to me as 1.8, so it goes to the other side and gets multiplied with everything. So the absolute error in C will be 16% of 1.8. And definitely we have to divide this with 100, finish the percentage sign, and then get the answer. The answer comes out as plus minus 0.288, which can be written down as plus minus, or should be written down as plus minus 0.3, because absolute uncertainty is always going to be in one significant figures, and you can observe this in P1 MCQs or questions. When they give you the answer, there's always going to be in one significant figure. So it's not something to overlook. This is actually a rule. Question number 2. So spacecraft in deep space uses XYZ. Okay, fine. So you're familiar with the question, you're familiar with the setup, that's why you're here for the video. All right. So now the good thing about this question is that he's mentioned what is upwards and what's leftwards. So you're not confused about clockwise, anti-clockwise, left, right, up or down. Then it gives you the details about how the thrusters are functioning. And part A says, calculate the resultant moment. Now, it's quite possible that, so we have A is 60, thruster A is 60 newtons, and thruster C is 220. Thruster C in this direction is 220 newtons. This is in this direction, approximately 60 newtons. So there could be some imbalance between the moments generated. So if this is the center of gravity where all the distances are given from, the thruster C wants to produce a anti-clockwise moment, and 60 newtons wants to produce a clockwise moment. What we can do is calculate their moments and then figure out which one is greater, which one is smaller. So this one will be 60, since the formula for moment is force into perpendicular distance. So the perpendicular distance between the center of mass to the distance, which is 90 degrees like this, perpendicular distance, or the line of action of force. So this becomes 60 times 1.2. This becomes 60 times 1.2. 1.6. And then we have this one. This is 220 times 0.4. So if you want to find the resultant moment, you just have to subtract all of this together and see what answer do you get. So 60 into 1.6 minus 220 into 0.4. The answer comes out as 8.0 Newton meters. So this is extra, this is imbalance, or this is going to cause the rotation in this, because if this was in equilibrium, the resultant moment should have been 0. So the resultant moment come out as 8.0. You really don't need to worry about positive and negative signs, because he's not going to ask you something like that. Even if he does, you can figure out which one is greater and then suggest whether this is going to be 8 Newton meters clockwise or anti-clockwise. So that's not big of a deal. It's not a problem. Part 2, state and explain whether the forces A, C are a couple. Now, the forces on A is 60 newtons and the forces on C is 220. First, for something to be a couple, or for something to be in terms of rotating torque couple, the forces should be same. One of them is 60, one of them is 220. So that's the first thing that tells us that it's not a couple. So that's what I've written down here. They are not a couple. We've stated what they are not, because the magnitude of forces are not equal. The forces are not anti-parallel. What does that mean? I'll get to that later. And the forces act through the same point, basically saying the same thing, the last two bits. So the line of action of force of C goes through the center of gravity. The line of action of 60 goes through here. So since they're crossing a single point, it says that this cannot create a rotation. This cannot create a torque. There is some rotation. I would like to take that statement back. There is some rotation, but it cannot qualify as torque, because torque requires one of the forces to act like this, the forces to act like this. And if you notice, this line of action and this line of action, they do not coincide anywhere possible, right? Okay, so these are the conditions which enabled us to answer the question. Okay, last part, he says thruster A and C are now switched off. The spacecraft is stationary. Thruster B is activated at time t1. Thruster B is a big one. It's going to go upwards, or force it upwards, producing a constant force on the spacecraft until the fuel runs out at time t2. As the fuel is used, the total mass of spacecraft decreases, definitely. So sketch the variation of from t1 to t2. So from t1 to t2, thruster B is activated. Okay, thruster B is activated at t1. Since it's stationary, the graph has to start from origin. It's not moving at that time. And since A or C are not working at this moment, only B is working. So the speed will increase due to constant force. Now notice what's going to happen. The speed and time graph, if you notice, the gradient of this graph gives me the information about acceleration. So if I can predict what's going to happen with the acceleration, I can predict in mathematics terms what's going to happen to the graph. So using F equals to ma, I realize that the force is constant, okay? But if I want to find the acceleration, I have to make that the subject of the formula. This is going to be F divided by m. Now, since the fuel is being used up, mass is being reduced, force is constant, as he says in the question, constant force. So if mass is decreasing, what's going to happen to the acceleration? The acceleration is going to increase gradually. So if the acceleration is increasing, then the gradient should also be increasing. I could have drawn a line straight like this, but the problem with this line is that one thing or one aspect is complete. That is, the speed is increasing with the passage of time. That's accepted, that's fine. But the other problem is that the straight line shows us that the gradient is constant. We just figured out that the gradient cannot be constant because it represents acceleration. According to this equation, it shouldn't be. So the line would look something like this. Now, if you notice that the gradient in the early days is this, the gradient in the ending point is this. It's getting steeper and steeper, which is in line with our logic of gradient. So it's supposed to look like this. As I mentioned in my earlier lectures and earlier lessons, always find an equation for the graph if you can't predict what's going to happen or what is happening. And you will always find some solitude in acceleration, in the gradient idea or area under the graph, or something that you can figure out based on some formulas. Okay, so part C, he says they are now splits apart and carry your payload. Okay, fine. The average force of this, the payload for this time, the velocity of the payload increases by, now this is important, this is increases by not increases to. So it's a change, it's a delta. In the upwards direction, the combined mass of the carrier and payload is this. Okay. Principle of conservation of momentum, we're familiar with that. Sum of momentum before collisions is equal to sum of momentum after collision in an isolated system when there is no external force acting on it. This is important to state that the sum of momentums are equal and there is no external force acting on it. Now, this is going to be a show that part, which means that even if you can't solve this part, you can use the value in the next question. So please, if you are ever unable to solve, not be able to solve this question in which he says show that, or show that something is this, then don't lose hope. Please continue to the next question. You will definitely need that value somewhere else. Okay, so show that the mass of the payload is 230. So we have two options to solve this, and both will yield the same answer. So I could have said that F is equal to ma. The force axis is 5500 newtons. The mass is unknown, and the acceleration produced by that is 8.5, because we're interested in the delta V divided by delta T for the acceleration. So, and all of this happened in a time frame of 0.3 seconds, 36 seconds. So M from this question comes out as 232.9 kgs. This is option one. Let's try another option from the perspective of momentum. So F is equal to rate of change of momentum, which is going to be m into delta V. The mass is not changing at this point. So this will be 8.5 minus 0 divided by 0.36, or better still, since we're interested in the change, we should just talk about this as change, 8.5. When you solve this, this comes out as, and this is supposed to be equal to 5500 newtons because that's the F available, and we want to find M. M, if you find it this way, is also going to be 232.94 kgs, which up to two significant figures is supposed to be 230, and hence this is shown. This is our mass M. Then he says, calculate the magnitude of the change in velocity of the carrier. Now in this question, the same principle is invoked, the principle of conservation of momentum. So the momentum gained by, or the change in momentum of the payload should be equal to the change in momentum of the carrier. That's the logic. Now for the payload, what happened? Its mass was 230. The change in velocity was 8.5. And for the carrier, it would have been the total mass, I think, yeah, is 2.5 power 3. That's the combined mass. So if you just want to find the mass of the carrier, that will be 2500 minus 230 kgs, because 230 kg belong to the payload. Okay. So mass, which is 2500 minus 230, multiplied by the change in velocity of the payload, of the carrier. So once you solve this, the delta V is going to come out as 0.86 meters per second, which is going to be written here. There is another probably logic for this, an alternative approach in which we could have done delta P is equal to force multiplied by delta T, right? So this was going to be 5500 multiplied by 0.36. That comes out as 1980 Newton seconds. And if you consider this as equal to mass into change in velocity, so your delta V for the carrier is again going to come out as 0.87 meters per second. This was also acceptable. And the mass here would be for the carrier, which is 2500 minus 230. All right, let's move on to the next question. Question number 3. This was a very interesting question. It's a new type of question, but it's a good one. So it says that a system is attached like this. There are cables, and I know that in cables we have forces called tension, ST. So the spring is attached to fixed length using a pulley, XYZ, everything is given. The spring obeys Hooke's law, which means that we can use F equals to Kx or Ke. Spring constant is given. A force F acts on the spring. The tension in the cable is T. The pulley is in equilibrium, which means that the two forces in this direction, T and T, are being balanced by a force in the opposite direction by the spring. The spring is not allowing the system to open up beyond a certain point. So it says on the figure 3.2, draw labeled arrows to show the direction of forces acting on the pulley, which is completely fine because there are going to be two places where the forces are acting on the pulley. This is point this with T and this with T. And anywhere from the center to this point as F. If you visualize this as a single object, then this is what it will look like to you. 2 times the tension being compensated by a single spring as a free body diagram. So he says the force F is 110, determine T. If this is 110, then what is T? T is 2 times equal to F. So this is 2T equals to F. 2T equals 110. So T equals 55 newtons. Calculate the extension of the spring. And that's a very easy part because we can use Hooke's law, which is F equals to Kx. The force applied is 110. Spring constant is 250 because we're talking about the spring, right? Over here. So this is 110 newtons and this is 55 newtons each. Because the system is in equilibrium, there is no resultant force. So X in this case comes out as 0.44 meters. This will be 0.44. Next part he says, now notice what he has done to the springs. First, we had only one spring. Now he's added 2 springs. Now in this configuration, this is generally called a parallel configuration. In parallel configuration, the spring constant gets doubled. If there are 2 springs, it gets doubled, 3 springs, 3 times. And the reason behind this is that whatever the force is going to come from this side or this side, it gets equally divided among the springs, which reduces the force overall, reducing the extension overall, giving the impression that probably the spring constant has doubled. So no matter how you look at this, whatever perspective you choose to look at it from, the system in this situation is stiffer as compared to before. Let's see what the question is about. Identical spring, 250 Newton per meter connected in pulley, okay, fine. The tension in the cable is kept the same. The value is still the same. The pulley is still in equilibrium. Determine the extension of the spring in this case. So if you notice that the new spring constant should have been 500 newtons per meter, because in parallel, the spring constant or the total spring constant generally increases. So according to this, the extension should be F equals to Kx. The force is 110 equals to 500 multiplied by X. X would come out as 0.22 meters, exactly half of this part. As I mentioned earlier, that the force equally divides and the spring experiences half the force. This is one way of doing this. Or you can simply write down a statement or a logic that springs are combined, they're in parallel. Since springs are in parallel, the load, effort, or force is divided, leading to half a force, F by 2. Hence, the extension also decreases half or decreases to half. You can also show that working as F equals to Kx, and that will be 55 with 250 into X. Why 55? Because the force is now divided between 2 springs. And because we're talking about this in terms of a single spring, the spring constant is 250. We're dealing with a standard case. This also will produce the result as 0.22 meters. Statement and an explanation in terms of mathematics, but it's completely fine. The elastic potential energy in figure 3.1 is E1. So in this case, the elastic potential energy is E1. If we wanted to calculate it, this will be half Kx squared, which will become half into 250 into 0.44 squared. In the second case, he says this energy E2 is because of these 2 springs. So there are 2 ways to do this. 1 over 2 into 500 into 0.22 squared, double the spring constant, or you can think about both springs separately and then add them together. So this will be E2 equals to 1 by 2 into spring constant 250 and extension as 0.22 whole squared. a single spring, okay, and simply energy added with the second spring, which is half into 250 into 0.22 squared. Now notice, since they are being written down twice, instead of this, we have done this, okay? So even in terms of physics or even in terms of mathematics, it makes sense. So let's take the ratio of E1 over E2. So E1 was 1 by 2 into K into X whole squared. E2 was 1 over 2 into 2K into X by 2 whole squared. And we want to divide them together like this. You can deal with them in terms of algebra, or you can put in values. You will get the same answer. So this will be 1 over 2 into 250 into 0.44 whole squared divided by 1 over 2 into 500 into 0.22 whole squared. The final answer is going to come out as 2, so we can write down 2.0 as the ratio, which means that this system has twice as much elastic potential energy as this one. In some cases, that's a good idea. In some cases, it's not. So it depends on the application where you want them to be. Question number 4, very easy and very nice question in terms of double slit experiment. A laser emits visible light of single wavelength frequency in vacuum, X, Y, Z, whatever. It's a double slit experiment. So the equation we're going to use is A equals to lambda D. This is A. This is lambda, wherever that lambda may be. And this is D. The X is actually mentioned here, the gap between the fringes. It could be between the dark to dark fringes, could be between center of bright to the center of next bright. So that's probably the same. He is given us the value of A, he's given us the value of the sprint separation X, he's given the value of D. This question, please pause the video, or if you have the question paper with you, please memorize this marking scheme, because this question is repeated, and the explanation actually calls for how this pattern is established. First, this is the fundamental concept that light diffracts. You see, the light coming from here was supposed to be parallel wavefronts, but after crossing through the narrow gaps, it has converted or become circular wavefronts. The fact that it has become circular wavefronts tells us that this is going to undergo constructive and destructive interferences whenever it has a chance, when it spreads out to the screen. But that's the first step, okay? That's why we've written this down. And then it's all about your knowledge impression that the bright fringe is observed when there is constructive interference, and constructive interference can only happen when the path difference is n lambda and 0 degree phase difference. And dark fringes can only be observed when the path difference is n plus 1 by 2 lambda, which can be written down as n plus 1 by 2, this, and this could be written down as this, and lambda with phase difference of 180. So first you gave it a situation in which this has to be done to be able to see that, and then you just showed two facts in which constructive and destructive interferences were taking place. Calculate the frequency of light emitted by the laser. So again, we're using the formula AX equals to lambda D. He's asking about the frequency. We will find the lambda first. So A is 1 into 10 to the power minus 3. X is 3.3 millimeters. Be careful, this is milli, for God's sake. And this will be lambda, and D is 4.8 meters. So lambda comes out as 6.875 into 10 raised to the power minus 7 meters. Now we can use V equals to F lambda to find the frequency. Since it is a visible light, emits visible light, so from gamma to radio waves, they all move at same speed in vacuum. So this will be 6.875 into 10 raised to the power minus 7. The frequency comes out as 4.36 into 10 raised to the power 14. This is 14, and this will be 4.4 into 10 raised to the power 14 hertz. Question C, the double slit is removed. A second laser is then placed beside the first laser. The second laser produces visible light of a different frequency from that of the first laser. The beams of light from two sources overlap. And when we talk about overlap on the screen, we're talking about the interference pattern. Overlap. Explain why a steady pattern of bright and dark fringes is not formed on the screen. You see, if it is a different laser, a second laser, the idea is that this interference pattern can only happen when the wavelengths are same. Because if you answer this question, if you extend the question, then even the headlights of a vehicle, for example, if you're looking at the front of a vehicle or a car, for example, the car has two lights in front of it. These are two also the same sources. Seemingly, they produce the same colors. So if we are traveling on the road, for example, why don't we see the same pattern on the road? Why don't we see bright and dark fringes due to the light of our headlights? Why don't we see that? Because they are from different manufacturers. Even from the perspective of similar manufacturer or same manufacturers, it is impossible to make sure that every wavelength or the bulb that are using in here is exactly 100% copy of this. So it is very important that when we want to see this, the light should be of single wavelength, which technically we call as monochromatic. Otherwise, there's no point of creating the interference pattern. That's why what I've written down over here. The light sources are not coherent. When you talk about coherent, it's about the phase difference, not the path difference. So the phase difference is not constant, or it's not zero, and they do not have the same wavelength or frequency. They will have the same speed, but since they don't have these two favorable qualities, the interference pattern on the screen will not be visible, much like the pattern of a car on the ground. I hope you like the car. Anyways, question number 5, electricity based. It was an easy question this time. So we have parallel connection. There is some internal resistance. This is some internal resistance. And we have a parallel circuit, 5 volt EMF. These internal resistances take away the lost volts, and whatever is left on the outside here and here becomes the terminal potential difference. Okay, let's keep moving on. So it says the battery has an EMF of 5 into 4.7. The situation is explained to you. The resistance of X is 100. That's also given to you on the diagram. The Z varies with the light intensity, so because it's an LDR. So the graph of that is given to us over here. So state the Kirchhoff's first law. We understand how that works. It's the sum of all currents entering a junction is equal to sum of all currents leaving the junction. The intensity of Z is 130, so the current in the battery is 38. That's the battery current, which means that the current is coming from here. This is 38 milliamperes, and the light intensity is 130 watts. So if you go back to the graph, 130 will be 110, 20, and 30. 130 comes to this point, which is 2 boxes up, which is 120 ohms. So under these circumstances, the resistance of the component Z, or you can say RZ or Z, is equal to 130 ohms. But let's move on. The question is about show the potential difference is 4.8 volts. That's very easy to do. You see the current coming from the battery is also flowing through the internal resistance. And we can use V equals to IR to find how much voltage does the internal resistor consume or use up. And that will become the term leading to terminal potential difference. So EMF is equal to the terminal potential difference of the components plus the lost volts of the internal resistance. And we can solve this logically. You see, the voltage drop by the internal resistance will be 38 into 10 to the power minus 3 milliamps multiplied by its own resistance, which is 4.7 ohms. The voltage drop across the lost volt section is 0.1786 volts. Now, since the EMF is 5 volts, we will subtract this 0.1786 from it, because that's what we are left with. And the answer comes out as 4.82 volts, which is shown as 4.8 volts. That means that the battery was trying to give 5 volts. But if we connect a voltmeter across this position, for example, like this on the outside of the battery, like so, it will only show me 4.8 volts. Under this load, 0.2 approximately volts are being consumed by the internal resistance, which is not exactly 0.2. This is 0.17 or 18, but we've rounded it off so we can talk about that in that sense. Then he says, calculate the current I2 in Y. For this, we have to do a bit of circuit analysis. Okay. I2. Now, what we have done is, if this is the current coming from the battery, we now know that this is going to be 120 ohms from the graph. If we can find the current through I1, simply subtracting this from the battery current gives me the value of I2. So let's do that. So let's write this in statement. So the current from battery is 38 milliamps. The current in LDR branch will be, now notice that this is actually in parallel. Since this is and this branches are in parallel, they both will get 4.8 volts. That's why don't be worried about the fact that why am I using 4.8. So this is 4.8 volts divided by 100 plus 120. Why? Because these two resistors are in series with each other, this X and Y, which is why I will have to be adding them together. So the current through them comes out as 21.8 milliamps. Now the current coming from the battery is 38, and from I1, or from this path, with the current that's flowing into I1 is 21.8 milliamps. So from this took 21.8, so I2 will be the remaining current. That's the logic behind this. So I2 will be equal to 38 milliamps minus 21.8 milliamps equals, this is 16.2 milliamperes, which they have written down as 0.016. That's acceptable, or 16 into 10 raised to power minus 3 amps. That is also acceptable. Calculate the power dissipated in Y. Very easy question. So since we're looking at Y, we know the current through this branch today is going to be 0.016. We know it is in parallel to the battery, so the voltage is going to get is 4.8 volts. And now we're just left with simple formula for power, which is P equals IV. The current is 0.016. The voltage provided is 4.8, and the power comes out as 0.0768 watts, which will become 0.77 watts. The next question is also a repeated part. He says that the light intensity on Z decreases. Now we know about the LDRs. The resistance of LDRs are inversely proportional to light. That's a part of your memory. You should memorize this. So the light intensity is decreasing, the resistance increases. That's how you begin answering your question. State the effect. This is the effect. RZ increases. So if RZ increases, the resistance of this branch increases. And even if they are in parallel, we can use the formula 1 over resistance of Y plus 1 over resistance of X and Y equals 1 over RT, total resistance. Now, even if one of them increases, the overall resistance RT also increases. So the current supplied by the battery will decrease, or it will be decreased. Because what's happening right now is that the battery is looking at a resistor or a combination of resistors as a single resistor. If the resistance of that whole circuit increases, the current coming out from the battery decreases, because the EMF or potential difference has to be the same, is being provided. So when the current decreases, the current through the central internal resistance also decreases, which will cause less voltage drop on 4.7 ohms. If 4.7 ohms takes less voltage, then the terminal potential difference available to us, available to me on the outside, will increase, because there is less or a smaller drop inside. More voltage of the EMF is now available to the outside instead of taking care of its internal problems. That's what I've written down here, that RZ increases, increasing the total resistance circuit. This reduces the current from the battery. Lost volts decrease, because they were also being calculated by V equals to IR. If the current decreases, no matter what the resistance is, the voltage drop that they were going to take inside the battery also decreases, leaving more headroom, more possibilities, more energy, more voltage for you to access on the outside, which is going to cause increase in potential, terminal potential difference. Question 6 is very easy. And in question 6, we have fundamental particle. It says, what is a fundamental particle? We understand what that is. Cannot be broken down into smaller parts. And then we have particle Q. This particle Q is a meson and with a charge of 0. We know that mesons are made of quarks and antiquarks. That is part of my memory. That is what you are supposed to memorize. So it says determine the possible quark composition of Q. Could be any possibilities out of the 6. I'm giving you just a few of them. So it could be up and then anti-up. Could be U dash, or down and then anti-down, right? So this is D dash like this. It could be top or anti-top. It doesn't matter. And the charge, for the charge, it will be positive 2 by 3e and then dealt with negative 2 by 3e. That is what a meson is. Then we have baryons. Baryons have 3 charges, 3 quarks, and they are generally protons and neutrons. So that's a family tree that you have to memorize. You can go check out my lecture. I've summarized that in a single slide. The next question is particle Q has a mass of this. The kinetic energy is this. Calculate the speed of particle Q. That's not a problem. So kinetic energy equals to half mv squared. This is 2.1 and 10 raised to the power minus 16 equals 1 over 2 into mass is 0.67 U. So notice what U is in terms of the data booklet. So the data booklet is given as atomic mass unit, which is unified atomic mass, 1.66 minus 27 into V squared. Make sure to perform the algebra correctly and your answer will come out as 6.14 into 10 raised to the power 5, which becomes 6.1 into 10 raised to the power 5. I would advise you to write down the units here too, between the steps that you're taking. Last part, he says, radium, XYZ, nuclide, state the number of electrons in a neutral atom. So we know that the number of protons in this atom are 88, as written at the base. So if it's neutral, then the number of electrons should also be the same, because protons are positively charged and electrons, are negatively charged. If I want to make sure that they're neutral, I cannot remove them completely, but what I can do is that they have similar charges. So to balance it out completely, there should be 88 electrons here. A nucleus of radium, this undergoes a series of decay to form X. During process, 5 alphas and 4 betas are emitted. Determine the number of protons of the X. So X is formed by radium undergoing these decays. So radium was 22888, 22888. So the very first time, let's call this some B. And there are going to be 5 alphas, 4, 2. So this number reduces to 5 multiplied by 4, that becomes 20. So 228 minus 20 gets 208. Then 5 multiplied by 2 becomes 10. So 88 minus 10 gives us 78. So this number should be 78. Now this B further decays by releasing 4 beta particles like this one. So let's write down an equation for that for the second step. So B came out as 208 with 78, decays with 4 beta particles, beta negative to be precise, 0 minus 1, plus this is going to be nucleus X after these 2 processes. So the top number or the nucleon number for this will be 208 because beta is 0. It will not be affected. So number of, we can't do that right now, okay. And the number on the lower side will be, since this is negative 1, this will be added over here. So this has become 82. So 4 times minus 1 plus 82 leads to 78. So our calculations check out. We're perfectly fine over here. So now the atom looks like this, 208, 82. Number of protons will be 82. And number of neutrons will be 208 minus 82, which leads to 126. This is 126. The examiner wants to see the working. Please make sure that the workings is still in place. That is all for today. I'll see you next time.